Let's take a look at how we can use trigonometry to solve triangles. First of all, what does it mean to solve a triangle? And if we're asked to solve this triangle, what we are being asked is to identify the measures of all the sides and all of the angles. Now there's a couple of conventions to be aware of when you're talking about and labeling your triangle. First of all, we label angles with capital letters and we label sides with lowercase letters. The other thing is that where those letters go, we got angle A, angle B, and angle C. When we're talking about side A, it's going to be the side that's opposite the angle. So side B is opposite the angle B, and side C is going to be opposite of the angle C. Now we can set up our problem. And I'd encourage you to do this as well, that when you're trying to solve the triangle, instead of putting all those values back into the picture, label it like this, as angle A, angle B, and angle C, first of all. And when we look at these angles, we already know a couple of them. We can see right off the bat that angle A is 60 degrees. And of course, because there's the right angle mark on angle C, that means angle C is 90 degrees right there. Then it's real easy to see that, well, for any triangle, the sum of all of the angles has to be 180. So to find angle B, we're going to take 180, subtract the 90, which leaves us with 90, and then subtract the 60 as well, and that simplifies down to being 30 degrees. So there's our first, the first half of the problem is already done. We've got all of the angles identified. Next we have to find all of the sides. So we'll say side A, side B, and side C. And fill in whatever is already given. And we are already given that side C has a length of 14. So really when it comes down to this problem, we only got to figure out two values. Now, to find these side lengths using trigonometry, the first thing we have to do is identify one of these acute angles that we're going to use. And it doesn't really matter which one we use. I'm going to use this angle A since it's already here. Okay? And if I want to find side A, I recognize that A is opposite of angle A. And I'm already given the length of the hypotenuse. So thinking about an angle, its opposite side, and its hypotenuse, that sure sounds like sine to me. So we're going to use the sine of 60 degrees is going to be the opposite side over the hypotenuse. Right? And we create this little equation that we want to solve. Of course, if we're going to try and get A alone, to get rid of that 14, I just multiply both sides by 14. And A is going to equal 14 times the sine of 60 degrees. And of course, we're going to want to go over to the calculator and just type that in. Now be careful. When you are looking at your graphing calculator, you need to make sure that you are in degree mode before you type this in. To check the degree mode on your calculator, what you do is hit the mode button first on your TI-84. Then this menu will pop up, and if you look down about the third option there, this one is highlighted as radians, and we need to switch it over to degrees. So highlight degree and hit enter, and then you'll make sure that you're in degree mode. So when you type in 14 sine of 60, what you should get out is 12.1243565. You know, a big long decimal that is never ending, never repeating. What should we put down for our answer? What I want you to do is to go to 3 decimal places, and you can either round or truncate, but definitely go 3 decimal places. So that means the length of side A is going to be 12.124. All right. Now if we wanted to find the length of side B, we can again reference our angle A. Side B is its adjacent side, and that side C is the hypotenuse. So adjacent over hypotenuse, that's cosine. So cosine of angle A, that's 60 degrees, is going to be adjacent over hypotenuse. And then again, to get rid of that 14, we're going to multiply both sides by 14. So 14 times the cosine of 60 degrees. Head over to the calculator, tappy tap tap, and we get a nice number 7. And now, since we have all 3 angles and all 3 sides, this triangle is solved. Now, before you leave a problem like this, you should check to see if your answer makes sense. And how you would know if your answer makes sense is check out the smallest angle. Okay. The smallest angle should be paired with the smallest side. Similarly, the larger angle should be paired with the largest side. That's the case that we have here, so we can be fairly confident that we have the correct answer. In this example, we're asked to find x. Well, obviously it's right here. It's the hypotenuse. But of course it's not, asking for the location. We want to know the value of x. How long is that side? So take a look at the information that you're given. That x, that's the hypotenuse. And when we're thinking about this angle that we're given here, 24 degrees, the 11 is its opposite side. So we have an opposite and a hypotenuse. That sounds like sine. All right, so the sine of 24 degrees is 11 over x. To solve this one, we're not going to divide by 11. Instead, we get rid of the fraction by multiplying both sides by x. Now, it doesn't give us our solution right away. All it does is get rid of the fraction. So I got x times the sine of 24 degrees is equal to 11. To get rid of that sine 24 now and get x alone, we have to divide. So 11 divided by the sine of 24. So you go over to your calculator, take 11 divided by sine 24, and get 27.044. We can stop and ask ourselves if this does make sense, and we don't have all 3 sides to compare it to, but that x is the hypotenuse, so it should be the longest side. Since it is considerably longer than 11, we can be fairly confident in our answer. Let's take a look at this word problem. Joel walked 200 feet away from the base of a building and measured the angle of elevation at the top of the building to be 76 degrees. If Joel's eye level is at 6 feet, how tall is the building? One thing that I found can be confusing for some Algebra 2 students is this phrase here, angle of elevation. So I want to take a second and talk a little bit more about that. There's actually 2 phrases that go together, this angle of elevation and angle of depression. Angle of elevation is measured up from a horizon, angle of depression is measured down from the horizon. So not exactly from the same observer. If we think about this building here, and we've got Joel standing over here. If we're thinking about an angle of elevation from Joe's eyes, we measure our angle upwards. Like that. That would be an angle of elevation. An angle of depression would go from maybe the top of the building measured down. Anytime that if you think about maybe from the observer looking up, or if they were looking down this way, maybe to the bottom of the building because their eye level is up above it, that would be an angle of depression as well. Anytime we look up is elevation, down is depression. So back to the word problem here, where Joel's trying to measure how tall this very tall building is. One of the greatest tricks that we have when we're trying to solve word problems is to draw a picture. And in this case, we have a tall building. So I'm going to make my building right here. There's a bunch of windows in my building. There's maybe a doorway down here. But Joel is standing over here. Right? And he's looking up at the building. So that is to the top of the building. And the angle is measured from his eyes right here. So it's this angle that is 76 degrees. We do know that he's 200 feet away from the building. That would be this distance across. And that Joel's eyes are 6 feet up above the ground. And we want to find out how tall the building is. So maybe I call that B for building. When you draw your picture, since we're talking about trig, you really want to try and find a right triangle. And what I have drawn here is a good right triangle. I have my angle of 76 degrees. B is the opposite side, and that 200, that's the adjacent side. So thinking about opposite and adjacent, that sounds like tangent. So tangent of the angle, 76 degrees, is opposite over adjacent. Okay. Once we have this nice little trig equation, it's not too difficult to solve. Multiply both sides by 200. And we see that B is 200 times the tangent of 76, which is 802.156. Okay. But be careful. That's not how tall the building is. That's just how tall this side of the triangle is. They did throw in this extra caveat that Joel's eyes are 6 feet above the ground, which means this height, Joel's eyes, is 6 more feet. So we have to take that answer and add 6 feet to it. So the building is actually 808.156 feet tall. One last big idea I want to talk about is the inverse trig function. Now, we can use our calculator to calculate a lot of trig values. For instance, we use our calculator to find out that the sine of 50 degrees is equal to 0.766. Now, what the inverse trig function does is it finds the angle that has the given trig value. So we have two ways that we can write an inverse. We can say inverse like this, sine to a -1 power. But it would be the sine of 0.766 is going to equal 50 degrees. Notice that when we take the inverse, we're kind of switching our numbers around. That it's the sine of an angle measure that gives us a ratio, or the inverse sine of a ratio that gives us an angle measure. All right, so the inverse is going to give us the angle measure. The other way to write inverse is putting arc in front of it. So arc sine of 0.766 would equal 50 degrees as well. And that works for all of our trig values that we have inverse cosine of some value or arc cosine of some value, and same thing with tangent, that there's tangent inverse or arc tangent. Okay. And either way, what you get out of taking an inverse trig value is the angle measure. To use your calculator to help you evaluate some of these inverse trig values, you take a look at your calculator, and to type in inverse sine of 0.5, look at the sine button. If you notice right above it, right here, it says sine to the -1. That's what you want to use in order to find inverse sine. So to get that, you'd first hit second, up in this corner, then hit the sine button of 0.5 and hit equals, or enter after that. And you'll get a value of 30 degrees. That's the same thing with inverse tangent. Go ahead and try it on your calculator. Inverse tangent of 1, and you should get 45 degrees. Inverse trig functions are super helpful for us because we use inverses to solve equations. Like when we had x plus 3 is equal to 9. How do we solve that? Is by subtracting 3 from both sides. Now the reason we subtract 3 is because adding 3 and subtracting 3 are inverse operations. So when we go back to sine of A is equal to 2/5, and we want to find out what A is, we have to get rid of that sine function. So in order to get rid of a function, we have to use its inverse. So I'm going to take the inverse sine of A, and whatever I do to the left side, I do to the right side as well. So inverse sine of 2/5. Then the inverse sine and the sine will cancel, and we'll be left with A. A is equal to the inverse sine of 2/5. So we go over to our calculator, type that in, and what should come out is 23.598. Remember, that's an angle measure, so we should write that as degrees. If we want to solve this one, cosine of alpha is equal to 0.5. We go ahead and take the inverse cosine of cosine, and whatever we do to the left, we do to the right as well. So inverse cosine of 0.5. On the left, inverse cosine and cosine cancel, and we're left with alpha. And on the right, we type that in, and we should get 60 degrees. So let's finish up with one more of the solve the triangle type of problem. In order to set the problem up, it's a good idea to first just write out, we got angle L, angle M, and angle N. And of all of these, the only thing I know is that angle M is 90 degrees. We will also have to find side L, side M, and side N. And looking at my picture, the side opposite angle N is 6, so side N is 6, and the hypotenuse is 10, so that means that side M is 10. And now we have three different values that we're going to have to calculate. The first value I'm going to try and find is going to be this angle N. When I look at what else I'm given with the 6 and the 10, the 6 is the opposite side, the 10 is the hypotenuse. So opposite over hypotenuse is sine. That means that the sine of N is going to be 6 over 10. To calculate that, we have to get rid of the sine, so we'll use sine inverse, and N is going to be the inverse sine of 6/10. So we go over to the graphing calculator, and we get a value of 36.869, which means the angle measure of angle N is 36.869 degrees. To find the measure of angle L, we realize that angle L plus angle M plus angle N have to add up to be 180 degrees. So we subtract all of that off, and L should equal 53.131. So 53.131 degrees. And the last thing we have to calculate then is the length of side L. So this side being side L, we could use trig again. Again, let's use angle N, side L, and say the hypotenuse. So for angle N, side L is the adjacent side. Adjacent over hypotenuse is cosine. So we got cosine of N, that 36.869 degrees, is equal to adjacent over hypotenuse. So L is 10 times the cosine of the 36.869 degrees. And let's go tappy tap on the calculator, and we get an answer of 8.000094, which when we go to 3 decimal places is just 8. I do want to point one small thing out. We did have a right triangle, and one thing that we get with a right triangle is Pythagorean theorem. So a squared plus b squared is equal to c squared. And L squared would be then 100 minus 36. And we take the square root of that, and we get that L is equal to 8 exactly. So how come I got an exact 8 down here, but when we use trig, we got a little bit extra? And the reason for that is going to be round off error. If you go all the way back to the angle that we were using, we used cosine of that angle n. Angle n being this 36.869 degrees. But when we calculated that from using the inverse sine of 0.6, that wasn't what our calculator said. It said 36.8698965. There was a lot more decimals that came after it. We just rounded off, just truncated, cut it right off from there. And that's where that little bit of error comes in. The more decimals we use, the more accurate we would be. And that's why we go to 3 decimals, so that we get something fairly accurate.